This is Team Fried Chips, and we're proud to present Bombs and Balloons, an action 2D shooter game. So we have our main character, and he's wearing jet boots, so you can use him to move up and down, and he has a fancy gun, so you can use him to shoot as well. We have the balloons that spawn randomly anywhere on the screen, and they go up from the bottom to the top, and the bombs go in the opposite direction, and they too spawn randomly. The rules of the game are simple. You get 1 minute to shoot as many balloons as you can, and that'll increment your score. If instead you hit a bomb, you get a special surprise, which we will see shortly. For the controls, we're using the PMOD joystick 2, although the joystick supports 2D axis. We're only utilizing the Y to make the character move up and down, and the button underneath the joystick to shoot. In addition to that, the onboard buttons can also be used to play the game. We primarily kept that there because it helped us to work together simultaneously while the game was in development. But if for some reason you don't have access to the joystick, you can always play it right on the FPGA. So here you can see me play. You can see the nice little popping animation when I shoot the balloon, and the score goes up by 1 each time I do it. And you can see the clock on the other side of the screen. Notice that the bomb takes the balloon down with it when they collide, and that's intentional. We thought that would be a goofy feature, and this is a goofy game. So I'm trying my best not to shoot any bombs here, to run the clock down, just to show you that the game is functional from start to finish. Almost at the end now. And there you go. It's our game over screen. Now, let me show you a slightly better video. You can see the joystick in action up close. And this video will demonstrate what will happen if you actually shoot a bomb. Here it comes. So when you shoot a bomb, it comes at you, and you have to dodge it. If it hits you, it's instant game over. See, I've gotten quite good at it just from the testing alone. I dodge it a second time. Now I fail to dodge it, and I go boom, game over.
Okay, so this is the detailed block diagram of our project. We have the top module, which is connected to the input joystick or FPGA push buttons and the output monitor. Based on the user input, it generates the character vertical position and the shoot signal and passes them to the VGA module. The VGA module is also connected to the balloons and the bombs. They are generated using random number generator modules. And VGA module receives the positions of the bombs and the balloons. It is also connected to a VRAM module where the VRAM stores all the images of our game. The VGA module can request for a particular pixel, and it can receive the RGB values of that pixel. So based on the positions of the bombs, balloons, character, and also the bullet, it can draw them and passes the VGA output to the top module, and the top module then passes the VGA output to the monitor for displaying. Here is how we make the VRAM module. It is generated with a simple Python script, pixel converter.py, which you can find in the sprites VRAM generator folder. So the script first just takes the input directories of all the images. So as you can see, we have the images of the character, balloons, bombs, etc. Then it also takes the image width and height that we want to display on the screen. Then it opens a file called blockgram.v. It prints the initial Verilog codes for generating the module, and then it resizes all the images to the corresponding image height and width that we specified above. Then it scales down the RGB values to fit in 4 bits. And it keeps track of an address starting from 0, and for every address, it prints the RGB values, which is each pixel value in hex, and then it prints the ending codes for completing the code. With that, we can generate the blockgram.v, and as you can see, we have like for each address, we have a pixel value, which we can access through this adder variable. We can specify the address here, and in dout, we get the pixel values. Our VGA module is responsible for drawing all the sprites and showing all the text. There are 4 simple steps for drawing. We have shown an example here. And by the way, this VGA code was taken from our lab assignment 1. Most of the codes are from there. We just updated it for using it in our project. So the 4 steps are, we have to first iterate through all the pixels. As you can see in this always block, we are checking something with this VGA H count and VGA V count, which are the horizontal and vertical pixel position. Then we have to check if that pixel position corresponds to a sprite position. So as this is drawing a character, we have a character position X and Y. We also know the width and the height. So we can check if the pixel is falling into this rectangular region. And if so, we have to draw the character. So if yes, if this condition is met, then we calculate like where in the VRAM we have stored the character. And based on the pixel position, we can get the RGB values from that. So we first calculate the address, and that is passed to the VRAM module. And we have a variable called pixel data, which was the output of the VRAM. So in pixel data, we have the RGB values, which are set in the VGA R, G, and B, and passed to the top module for showing in the monitor. And if this condition is false, we just simply draw a black pixel. That's how by replicating this block multiple times for different images, we can show all the images.
I will explain how we implemented collision detection in our game. We need collision detection to check if any bullet hits any of the balloons and if any bombs hit any of the balloons. Both collision detections are implemented inside the balloon module, which basically check whether any of the bullets or bombs hit that particular balloon. This code snippet is specifically for checking whether any of the bullets collided with our balloon. And you can see that we have a generate block, and we are iterating through each bullet using a for loop. And in this logic, this is where we check whether the ith bullet collided with the balloon. And bullets coordinates are denoted from bullet underscore X and bullet underscore Y. And we have the balloons coordinate with the X and Y. This logic can be easily explained from this figure where we have our screen and coordinates of each sprite. So in this logic, we are basically checking whether the bullet coordinate is inside the balloon sprite. We have balloon height, balloon width, and using those measurements, we check whether the bullet coordinate is inside this square of the balloon sprite. And if so, we send out a disable signal to the VGA module, which starts the popping up animation of this balloon. And when the balloon get respawned again in the screen after some time, so this logic checks that condition, and when that happens, it send out the enable signal again to VGA module to show the balloon again. And we have implemented collision with bombs in a very similar logic. and both these collision logics are in balloon module inside the balloon.v file. This is it for our bombs and balloons game demonstration video. We have open sourced our game in this link. You can see all the details required to re-implement the game and play the game in FPGA. We would love to hear your feedback if you play the game. Feel free to let us know. And thank you for listening. Have a wonderful day.